Oxidation of alkene. There are two types of oxidation. Please write down. There are two types of oxidation of alkenes. The first one is the mild oxidation. The first one is the mild oxidation, and the second one is the strong oxidation. The first one is the mild oxidation. When we add alkenes with cold dilute KMnO4 at room temperature, they undergo a mild oxidation, right? So the reagent is cold dilute acidified. In chemistry, when we say cold, it means it is at room temperature. Okay, it's a cold dilute acidified or alkaline KMnO4. When we say this, it means it is at room temperature, and the condition for this is room temperature, no heating. And we know that KMnO4 is purple. In this reaction, obviously, it's going to turn colorless. Okay, now what is the mild oxidation says? When you do the mild oxidation, and we all know KMnO4s are never written in organic chemistry with their complete formulas. Their symbols are used, and their symbol is always atomic oxygen. So whenever you have to write KMnO4 in the equation in organic chemistry, you have to write just one atomic oxygen in the brackets. That will tell you that this means KMnO4, right? So adds a cold dilute. So I'm going to also write H2O with it. Dilute mean a lot of water. H2O ko I used to write, or in organic HOH, right? So it's a cold dilute KMnO4. It's a straightforward, for the sake of uh, memorization, I'm telling you, double bond is converted into single bond, and both these carbons, where double bond was present, they have one more valency to attach. So two OH attached here. Yes, so it's turning into a diol technically, right? So I just put this OH. Listen, everyone, this OH and this OH, they are added together. Okay, so you can say like this: okay, this OH and this OH, one carbon each. So ethane 1,2 diol is formed from ethene. So it is always the same product that the diol is formed. In this case, it is ethane 1,2 diol. If we have, let's say, propene, yes, it's symbol KMnO4. When you write in the equation, if you write full KMnO4, then you have to write the byproducts which KMnO4 turns into. So therefore, in organic chemistry, we are allowed that we use their symbol, and their symbol is not O2. Their symbol is atomic oxygen when you put a bracket around that. For example, in this case, even you don't write any other thing. You just write MnO4 negative slash OH negative RT. So I added alkaline KMnO4 at room temperature. I know what will be the product. The both carbons which are having double bond. Yes, so they are double bond turn into single bond, and the CHOH on this carbon and CH2OH on this carbon. So propane 1,2 diol is formed. Even whatever the alkene is, even if I have a cyclic alkene like this, for example. So I just you have to make your concept clear that whatever alkene we have, for example, this one, look, and we add with cold dilute KMnO4 at room temperature and pressure. These signs mean that the same reagent condition which were used in the upper reaction we are going to use here. So it's a cycloalkene. It's a cycloalkene. But we know the concept. When alkenes undergo cold dilute KMnO4 room temperature, their double bond breaks, and both these carbons which are having double bonds now will have two OH single bond and two OH attached. So what will be the product? Yes, cyclohexanediol. Okay, right. So if there are more than two double bonds, so more than one double bond, so they turn into diol. So it's a straightforward, right? So when alkenes undergo mild oxidation, they turn into diols. Okay, so चार OH आ जाएंगे. If there are more than one double bonds, all of them will be like this: CH2, CH, then CH2, CH, double bond CH2. So now here is the OH, 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 OH. So it's tetraol that is going to be formed in this case. Okay. So second type is strong oxidation. All these four carbons are going to have OH now. The product will be like this: CH2OH, then CHOH, and then CH2, and then CHOH, and then CH2OH. So all these carbons are going to have OH. So the second type is the strong oxidation. Oxidation of cyclohexane included or excluded? Yes. Okay, so let's stop here. We'll continue this the strong oxidation in the next class, right?